Hi, this is Danielle, and today I am solving a related rate problem for calculus. In this problem, we are told the volume of a cube is increasing at a rate of 10 centimeters cubed per minute. We are asked how fast is the surface area increasing when the length of an edge is 30 centimeters. To start out, we'll go ahead and draw a picture of a cube and label our sides. I like to label using x as my variable. And then before we do anything else, we were given the rate of the volume. So I'm going to write that in the corner here as dV over dt to symbolize the rate of my volume. And that was equal to 10 centimeters cubed per minute. Since we are dealing with volume and surface area, it's also good to go ahead and write out those equations. Our volume is going to be equal to our length times width times height, and all those values are equal to x. So that ends up just being v is equal to x cubed. And our surface area is equal to the length times width, and for each side of the cube. So we have 6 sides, and that will end up being 6x squared for our total surface area. For the next step, it's best to go ahead and take that derivative of the top function, our volume function, and when we do that, we're going to be left with dv dt on the left and 3x squared dx dt on the right. You might notice here that we now have this dx dt, and we were not given dx dt, we were only given dv dt. The same thing would happen if we took the derivative of this bottom function first. We would still have that x value, which would result in that dx dt, and we're not given that. However, if you look at this equation, we were given dv dt, and we were also given our x value. So if we just go ahead and plug in those values, then we can go ahead and solve for dx dt. And whenever we go to plug that into our bottom equation here, when we have our dx dt, we'll now have that value that we can go ahead and plug in. So if you want to take a second and try to plug that into your calculator, what you'll be left with is 1 over 270. And that's your dx dt value. Now from here, we can go ahead and take the derivative of our second equation, our surface area equation, and that's going to look like this here. This is just saying that I am taking the derivative of both sides. That's what this means. And that will leave us with ds dt is equal to 12x dx dt. And from here, we now have all the values on the right side here, and the rate of the surface area is what we were looking to solve for. So this is perfect. We can go ahead and plug in those values. So we get 12 times 30 times 1 over 270. And again, if you'd like to take a moment, go ahead and plug that into your calculator. Then what we will be left with here is going to be 4 over 3. Now in terms of units, I think the easiest way that I recognize what the units are for this particular problem is we are solving for surface area. And you might have noticed in our equation here, surface area is going to be a value squared, because we're taking two variables multiplied by one another. So that's going to be true with the units as well. So it's going to be centimeters squared per minute. And there's your final answer. This is the rate in which our surface area is increasing when the length of the edge is 30 centimeters.